दिस इज रेल कॉरिडोर डिजिटल एलिवेशन मॉडल, जो कि लिडार से ही आया है। अब यहाँ पे जो डिफरेंट कलर्स हैं, डिफरेंट कलर्स डिपिक्ट्स डिफरेंट ऑल्टीट्यूड। ये आप यहाँ पे देखेंगे कि 400 मीटर से लेकर के 400 मीटर का एलिवेशन डेटा है, और ये डिस्टेंस है। इस जगह पे मान लीजिए 50 मीटर पे यहाँ पे जो हाइट है वो 358 से कम है, या इस वाले जगह पे हाइट इतनी है। ये जो है ये ग्राफ आपको क्रॉस सेक्शन उसका दिखा रहा है। एक्यूरेट क्वांटिटी एस्टिमेशन, L section, cross section, anywhere in the available data, even at every meter you can have it, because it has so many points. 50 centimeter contours are very much possible with this data. LIDAR survey technology for doubling, जैसे मैंने अभी आपको पीछे शो किया था उसी का enhanced photo है ये. This is our data from Khairar Bhimsen project, NCR के लिए जो हमने किया था. This is the actual data. So the benefits of LIDAR technology, track level LIDAR survey technology for doubling projects for Indian Railways are, it is faster, survey data collection up to 100 to 150 kilometer in one day. It is accurate, laser based accurate measurement less than 5 centimeter RMSE, precise quantity estimation, pricing equivalent to drone aerial survey, more information, it has 100 times more information than total station survey, because total station तो एक certain distance पे होता है, और यहाँ पे तो 1 स्क्वायर मीटर में आपके पास 30 से 38 पॉइंट्स हैं. Insight, realistic visualization through LIDAR and geo video. Extraordinary because it can penetrate trees, vegetation along the alignment. Compatible, it is 100% compatible with Bentley, Quantum and AutoCAD, which are used by railways. All situation dependable because it can survey in day, night, rainy season, summer, winter, every time. Reduces repeated site visits. Add data on vertical features like OHE, transmission line, F-foot over bridges everywhere. So these are the major benefits of LIDAR. So what are the factors for accurate data from LIDAR? Let's talk about that. बिकॉज ऐसा नहीं है कि कोई भी लिडार स्कैनर लेकर आ गया किसी भी गाड़ी पे या ट्रॉली पे लगा दिया और लिडार डेटा एक्यूरेट आ गया. उसके लिए कुछ इंपॉर्टेंट फैक्टर्स हैं जिनको अगर फॉलो नहीं किया गया तो लिडार डेटा एक्यूरेट नहीं होगा. दे विल बी जस्ट पॉइंट्स. सो टेंडर में आपको क्लियर स्पेसिफिकेशन लिखनी होगी कि आपको कैसी एक्यूरेसी चाहिए, कैसी पॉइंट डेंसिटी चाहिए, व्हाट आर द डिलीवरेबल्स फॉर द प्रोजेक्ट जिसके लिए आप लिडार डेटा यूज करने जाते हैं. लिडार सिस्टम का कैलिब्रेशन शुड बी वेरी गुड. कैलिब्रेशन मतलब कि स्कैनर, डीजीपीएस सिस्टम और आईएमयू यूनिट, जो 3 यूनिट्स मैंने बताई थी कि हर लिडार सिस्टम में होती हैं, दे शुड बी कनेक्टेड वेरी प्रॉपरली. ऐसा नहीं हो कि जो पॉइंट्स आ रहे हैं वो डीजीपीएस से कनेक्टेड नहीं हो और उसकी वजह से आपको ग्राउंड कोऑर्डिनेट्स ही ना मिले उन XYZ को उसके. और अगर उसका आईएमयू ठीक से काम नहीं कर रहा होगा, कोऑर्डिनेटेड नहीं होगा, तो जो वाइब्रेशंस होते हैं उस सिस्टम के जिसपे कि ये स्कैनर लगा है उसकी वजह से पॉइंट्स की पोजिशनल एक्यूरेसी खराब हो सकती है और आपका जो डेटा है वो एक्यूरेट नहीं आएगा. ट्रेजेक्टरी कैलकुलेशन, precise georeferencing of lesser points, filtration and classification of point, which is very necessary कि after data acquisition, if you don't have the process, prescribed softwares for this particular thing for classification and filtration of point, then also your LIDAR data will not be accurate. Ground truthing, NSSDA accuracy report. This is national standard for spatial data accuracy. This is a report which should be required by every railway official to check the accuracy of the data. अगर वो कोई ऐसा है जो ये नहीं दे रहा है, इसका मतलब उसका डेटा उतना एक्यूरेट नहीं होगा. So second technology is photogrammetry based survey. Photogrammetry based survey is actually is the 3D. अगर हम बहुत क्रूड भाषा में बात करें तो 3D सर्वे होता है जिसमें कि X, Y, Z तीनों कोऑर्डिनेट्स आते हैं का कैलकुलेशन किया जाता है विद द हेल्प ऑफ इमेजेस. This is photogrammetry. It is science of making measurement from photographs, especially for recovering the exact position of surface points. This is how this images shows कि कैसे photographs लिए जाते हैं with the help of drone. ये एयरक्राफ्ट है, ऐसे ही सेम सिस्टम होता है ड्रोन से भी लेने का. दिस इज अ प्रोसेसिंग सिस्टम जिसमें ड्रोन डेटा को जिसमें कि फोटोग्रामेट्री डेटा को प्रोसेस किया जाता है. दिस इज अ स्टीरियोस्कोप जो कि बहुत पहले जब इंजीनियरिंग कॉलेजेस वगैरह में 3D का कॉन्सेप्ट जब दिया जाता था तो इसकी स्टीरियोस्कोप की हेल्प से ही दिया जाता था, 2 फोटोज रख के. और इस स्टीरियोस्कोप की मदद से इस एक पर्टिकुलर एरिया पे 3D दिखता था. शायद बहुत से लोग जो यहाँ पे हैं उन्होंने किया भी होगा उसको. So stereophotogrammetry involves estimating the three-dimensional coordinates of points on an object, employing measurements made in 2 or more photographic images captured from different positions. Because they are captured from different positions, so using the concept of parallax, we can have a 3D vision in this. And so this is the basis of photogrammetry technology. This is the basis of how to obtain 3D data. So for photogrammetry technology, images can be taken from drone or UAV, which are the low altitude images. You can take images from manned aircraft also, which are medium altitude, and from satellite, which is high altitude. क्योंकि वो तो बहुत ही ऊपर होते हैं. So photogrammetry technology, the images, it is basically measurements on images using the overlapping images basically, जिसकी help से you can have a 3D view and you can measure those things in ground control coordinates. The images can be taken using drone, which are the low altitude image, because drone की height हम खुद control कर सकते हैं. Another is manned aircraft, medium altitude. Drone के usage से पहले सारा पूरा photogrammetry process was based on this manned aircraft images. And another is satellite images. Satellite जो कि इंडिया की जैसे कार्टोसेट सैटेलाइट है उससे इमेजेस थ्रू NRSA प्रोक्योर करके और उसके ऊपर हम फोटोग्रामेट्री करते हैं. सो अब सबसे पहले सैटेलाइट फोटोग्रामेट्री की बात करते हैं. इन सब के अलग अलग एक्चुअली यूसेज हैं. स्पेशली सैटेलाइट फोटोग्रामेट्री वहां यूज की जाती है जब आपको बड़े कॉरिडोर्स के सर्वे करने हैं, क्योंकि सैटेलाइट फोटोग्रामेट्री में बहुत बड़ा एरिया कवर हो जाता है, बिकॉज दे आर टेकन फ्रॉम वेरी हाई ऑल्टीट्यूड. तो ये है सैटेलाइट फोटोग्रामेट्री फॉर लार्ज एरियल सर्वे, फॉर PET PFR सर्वे. इसमें क्या है कि डिफरेंट रेजोल्यूशन की इमेजेस होती हैं. लाइक 250 सेंटीमीटर रेजोल्यूशन की अगर कोई इमेज है तो उससे 10 मीटर्स का कॉन्टूर्स बना सकते हैं. मैप स्केल होगा 1:10,000 का. अगर 100 सेंटीमीटर रेजोल्यूशन की इमेज है तो उससे 2 to 3 मीटर का कॉन्टूर बन सकता है. मैप स्केल 1:5,000. 50 सेंटीमीटर रेजोल्यूशन की इमेज में 1 to 2 मीटर का कॉन्टूर्स बनता है. मैप स्केल इज 1:2,000. एंड 30 सेंटीमीटर रेजोल्यूशन की इमेज में 1 मीटर का कॉन्टूर बनता है. मैप स्केल इज 1:1,000. So Matrix Geo Solution has done lots of projects for satellite photogrammetry. This image is from DFCC for a high-speed railway corridor project. Matrix Geo executed 8,000 plus kilometer railway corridor survey for PET, DFR, FLS studies. It was done for DFCC for Ahmedabad, Mumbai, Delhi, Chandigarh, Amritsar, Delhi, Mumbai, Chennai. These are projects are for high-speed railway projects. Almost all the corridors for high-speed railway projects are done by Matrix Geo Solutions. And one very prestigious and very nice project, I personally like this project. This is from Bilaspur, Manali Leh. Satellite photogrammetry survey में बता रही थी. We have done almost all the corridors for high-speed railway projects. And apart from that, Bilaspur Manali Leh project also we have done for satellite photogrammetry. So I will tell you a brief about how we executed this Bilaspur Manali Leh project, because it was a prestigious and a very challenging project. It was done for Northern Railway. And so about this project, Bilaspur Manali Leh line is a proposed high elevation all weather 1676 millimeter 5 feet to 5 feet 6 inch broad gauge railway track that is planned to connect Bilaspur in Himachal Pradesh to Leh in Ladakh, Union Territory of India. The expected length was 475 kilometer. It would become the highest railway track in the world. all-weather railway connectivity from Himachal Pradesh to Leh, strategic significance to be the most difficult railway project in the country. So Bilaspur Manali Leh total area was 5,064.2 square kilometer. It is the highest railway track in the world, most difficult railway project in the country. Processed 480 square kilometer Upsi Leh section within 15 days of time only. The deliverables were orthophoto, DEM, topographical map, and as I told you, along with these outputs, we have given NSSDA report to prove the accuracy the accuracy which we committed, we have delivered that, and we have given a delivery report along with that. So this was the project team. In this project, Northern Railway and a Turkish company, Yuxen, and Matrix Geo Solution were the part. They used to come to our office for they were continuously monitoring the processing part in our office. They used to come and see that. This is the deputy chief engineer who was involved in that project. So he was taking information for which drone we are using and how we use that. This is, they closely monitor the processing of the data. So this were the stages. DEM creation using satellite imagery. Then we prepared alignment report, stage 1. Geological mapping, geophysics studies were done. Approval of alternative alignments, LIDAR survey. Alignment report, stage 2. Detailed geological mapping. Approval of alternative alignment and staking of centerline and ROW. So the steps were, first step was input quality checking and inventory report preparation, in which we check the satellite imageries that they are fine or not. Does they have any cloud cover? Does they have so much of a snow cover कि वो दिख ही नहीं पाएगा उसमें वो जगह? तो उन चीजों के लिए satellite imagery की checking की जाती है. Satellite imagery quality checking and report preparation. Selection of the location of PCPs, that is principal control points. Preparation of monographs of principal control points establishment. Second step was processing of satellite imagery. So we performed aerial triangulation, NSSDA report preparation, checking the result as per ASPRS standards, 3D topographical map generation by stereo equipment, generation of digital terrain model in suitable accuracy as per ASPRS accuracy standards, generation of digital elevation model with 1 meter interval in suitable accuracy as per ASPRS standards, application of visual enhancements. Third was quality checking and delivery. So checking and approval process was done. Then submission of all the raw data, processed data, deliverables and relevant documents were done. Reports and field books were also delivered to them. So first input reception, that is receiving of image, then conversion of those image from TIL using IMD files provided along the images. Following parameters are checked: GSD and off nadir angle, type of satellite image, that because there are various types of satellite images. The image required for this particular project was WorldView 2 and WorldView 3 image. So we need to check whether the images delivered to us are the same or not. Then the time and date of images. We need to check whether these images are not very old, because अगर वो old होगी तो समय के साथ वहाँ की topographical conditions change हो जाएंगी. So time and date of the images are very important factor while we are doing satellite photogrammetry. This is a kind of inventory report जिसमें मैंने बताया कि उसमें उसका GSD चेक करते हैं, नादिर एंगल चेक करते हैं, स्टीरियो इमेज है कि मोनो इमेज है वो चेक करते हैं. उसका GSD क्या है? GSD इज ग्राउंड सैंपल डिस्टेंस. 1 पिक्सल में ग्राउंड का कितना पार्ट आएगा. देन उसमें ये कमेंट करते हैं कि वो लो रेजोल्यूशन है कि हाई रेजोल्यूशन है. जैसे यहाँ पे आप देखिए एक इमेज में 0.5 का GSD है. तो हमने उसको मार्क कर दिया कि वो लो रेजोल्यूशन है, हमें 30 सेंटीमीटर जीएसडी या 0.3 मीटर जीएसडी की ही इमेजेस चाहिए जो कि हाई रेजोल्यूशन इमेज है। तो इस तरह की रिपोर्ट प्रिपेयर करके हम क्लाइंट को भेज देते हैं ताकि वो इमेजेस को फिर से रीऑर्डर कर सके। दिस इज ऑल्सो काइंड ऑफ इन्वेंट्री रिपोर्ट। इसमें हमने, जैसे मैंने बताया, गैप्स के लिए चेक करते हैं, क्लाउड कवरेज के लिए चेक करते हैं। अगर बहुत ज्यादा क्लाउड कवरेज है तो उन इमेजेस पे काम नहीं किया जा सकता, या स्नो कवरेज है तो इन इमेजेस पे काम नहीं किया जा सकता। जैसे कि आप देख रहे होंगे कि जो रेड मार्क्ड है उसका मतलब है कि वो डिजायर्ड लिमिट से ज्यादा है, हमने उनको मार्क करके भेज दिया कि हम उसके बाद वाली, हमें उस जगह की इस पर्टिकुलर इमेज आईडी दूसरी नई चाहिए होगी जिसमें कि स्नो कवरेज और क्लाउड कवरेज ना हो इतना। तो कमेंट्स क्या है? वी रिकमेंड दैट इमेजेस व्हिच आर हैविंग मोर देन 20% ऑफ क्लाउड और स्नो नीड टू बी रिप्लेस्ड टू अचीव द डिजायर्ड एक्यूरेसी व्हिच आर शोन इन अबव शीट। These are the monographs जो कि ग्राउंड कंट्रोल पॉइंट्स या जिन्हें प्रिंसिपल कंट्रोल पॉइंट्स भी कहते हैं उसके लिए यूज होता है। ये इस जीसीपी के लिए, ये हम यहाँ पे ये दिखा रहे हैं कि ये पर्टिकुलर जीसीपी ग्राउंड कंट्रोल पॉइंट इस पर्टिकुलर लोकेशन पे लगा है, उसकी ईस्टिंग, नॉर्दिंग और एलिवेशन ये है। सो नाउ सबसे पहला स्टेप जो फोटोग्रामेट्री करने के लिए होता है दैट इज एरियल ट्रायंगुलेशन। Now, what is aerial triangulation? Aerial triangulation represents the mathematical process of establishing precise and accurate relationship between individual image and ground. जैसे मैंने आपको बताया, images तो ऊपर से ली गई हैं, images तो ड्रोन से या एयरक्राफ्ट से ली गई हैं। तो जो images होती हैं उनमें जो कोऑर्डिनेट्स होते हैं वो फोटो कोऑर्डिनेट्स होते हैं। लेकिन अगर मैं आपको पूरा डेटा प्रोसेस करके दे दूं जो कि फोटो कोऑर्डिनेट में हो, उसका ग्राउंड कोऑर्डिनेट से कुछ लेना देना, उसका हमारे रियल ग्राउंड से कुछ लेना देना ही ना हो, तो उस प्रोजेक्ट का, उस आउटपुट का आपके लिए कोई भी यूज नहीं है। तो फोटोग्रामेट्री करने के लिए इसलिए जो फर्स्ट स्टेप होता है वो होता है फोटो कोऑर्डिनेट सिस्टम को ग्राउंड कोऑर्डिनेट सिस्टम पे कन्वर्ट करना, ताकि जो भी आपको एक्स वाई जेड की वैल्यूज मिले वो ग्राउंड कोऑर्डिनेट्स में हो, जो कि आपके लिए यूजेबल हो। So inputs for the project was we used WorldView 3 satellite imagery जो कि 30 सेंटीमीटर रेजोल्यूशन की होती है, और ग्राउंड कंट्रोल पॉइंट्स फ्रॉम द फील्ड। सबसे पहले, जैसे पहले जो एक कन्वेंशनल टेक्नोलॉजी है हमारी जिसमें कि टोटल स्टेशन से जाके ग्राउंड कंट्रोल पॉइंट्स लिए जाते हैं, हम उसको मॉडर्न सर्वे के साथ मिक्स करते हैं टू अचीव अ वेरी हाई एक्यूरेसी and to give you more desirable results. अब ये थोड़ा टेक्निकल चीज है कि एटी में क्या क्या होता है। सबसे पहले ब्लॉक सेटअप यूजिंग आरपीसी, देन टाई पॉइंट मेजरमेंट, then ground control point measurement and bundle block adjustment finally to convert the photo coordinates into ground coordinates. This is a kind of a quality check NASDA report which we prepare and give to client to show that the accuracy we committed, we are giving that accuracy only. This is also a NASDA report. Now, digital elevation model. Digital elevation model जैसे नाम से ही पता चल रहा है, elevation model है, टेरेन में कहाँ कहाँ हाइट डिफरेंस है, या ये कहें क्या क्या हाइट्स आ रही हैं, उस हाइट के हिसाब से टेरेन को पूरा मॉडल करना, दैट इज डिजिटल एलिवेशन मॉडल, जस्ट ऑन द बेसिस ऑफ द हाइट ऑफ ग्राउंड, दैट इज डिजिटल एलिवेशन मॉडल। तो ये बिलासपुर मनाली लेह का एक्चुअल डिजिटल एलिवेशन मॉडल है, जहां पे आप देख सकते हैं ये जो पूरा रेड कलर है, ये साइड में आप एक स्केल देख रहे होंगे, तो रेड कलर वाली जगह जो है उनकी हाइट है 4707 मीटर। तो यहाँ पे जो हाइट का वेरिएशन है दैट इज फ्रॉम 4700 मीटर टू 3250 मीटर। उसके हिसाब से ये पूरे डिफरेंट कलर्स जो है वो डिफरेंट हाइट्स को डिपिक्ट कर रहे हैं। दिस इज अ क्रॉस सेक्शन, ये जो आप ये देख रहे हो, ये जो आ रहा है, दिस इज अ क्रॉस सेक्शन ऑफ दिस पर्टिकुलर एरिया जहाँ पे ये येलो लाइन दिख रही है आपको। तो क्या, जैसे मैंने बताया, हर 1 मीटर पे आप क्रॉस सेक्शन ले सकते हैं, क्योंकि ये इतना ज्यादा एक्यूरेट होते हैं ये मॉडल्स। तो ये उसका क्रॉस सेक्शन है। नाउ डिजिटल टेरेन मॉडल का क्वालिटी चेक कैसे होता है? Principal control point and checkpoints values are compared with DTM points and reports are prepared. Manual and tool-based checks were performed to ensure accuracy of DTM as per specification. Quality statistics report in comparison to check and ground control points available. Manual check for accuracy and edge matching is done. This is the quality check report of digital elevation model. Now this is orthophoto, the one which I told you that this is one of the major benefits of modern survey technology. You have in your background, you have the image of your site, and that image is not just an image, it is a scaled map जो कि आप measure कर सकते हो in X and Y. You cannot measure the Z coordinate, the elevation from these images, but X and Y को बहुत ही precisely within 5 to 10 सेंटीमीटर एक्यूरेसी आप मेजर कर सकते हैं। तो जो भी हम आउटपुट देते हैं, मान लीजिए मैंने आपको ये डिजिटल एलिवेशन मॉडल दिया हुआ है और उसके साथ में आप ये ऑर्थोफोटो लगा लेंगे, तो आपको पता चल जाएगा कि हाँ, जहां पे हाइट, जहां पे माउंटेन पीक्स दिख रही है, वहीं पे इनका रेड कलर का पॉइंट आया है, यानी कि वहीं पे हाई ऑल्टीट्यूड एरिया, या जहां पे ब्लू कलर दिख रहा है वहां पे वैली एरिया ही है, लो एलिवेशन एरिया ही है। इसके साथ साथ ऑर्थोफोटो का सबसे ज्यादा अच्छा यूज है वेक्टर डेटा देखने में, वो मैं आपको बताऊंगी कि टोपोग्राफिकल मैप कैसे दिखता है उसमें। फिर ऑर्थोफोटो जनरेशन के लिए क्वालिटी कंट्रोल स्टैंडर्ड्स क्या होते हैं? ग्राउंड कंट्रोल पॉइंट्स आर चेक बाय सुपर इम्पोजिंग ओवर ऑर्थोफोटो। जैसे मैंने आपको पीछे एक इमेज दिखाई थी, उस इमेज में एक फोटो थी जिसमें था कि इस कॉर्नर पे एक कंट्रोल पॉइंट लगाया हुआ है। आप हमारी ऑर्थो फोटो पर भी उसको वेरीफाई कर सकते हैं कि उस जगह पे वाकई में वो पॉइंट लगाया है या केवल फोटो ही खींच के दे दी, उस जगह की पॉइंट लगा ही नहीं था। So vector data is compared with orthophoto. Color balancing is verified. Edge matching is done between two blocks. Individual scene orthorectification using triangulated satellite imageries and DTM. Verify the geometric accuracy of the ortho using the available control points. Seam line, cut line generation. Edit the seam line, ensuring that seam line does not cross important cultural features. Selection of the seam lines along roads, rivers, streams. Review of tone balance in the mosaic. Cutting the overall mosaic in tile based in the file size. This is a 3D topographical map जो मैं आपको बता रही थी। इसमें आप देख रहे होंगे डिफरेंट कलर्स की लाइंस दिख रही हैं। एक्चुअली डिफरेंट कलर लाइंस आर सिंबलाइजिंग डिफरेंट फीचर्स। जैसे एक ये लाइट ब्लू कलर की है, तो ये एक सिंगल लाइन स्ट्रीम को दिखा रही है। ये जो ये रेड से कलर की या डार्क ब्लू कलर की है, ये जो ये रेड कलर वाली लाइन है, ये रोड्स को दिखा रही हैं, जो पेव्ड या अनपेव्ड रोड्स होंगी वहां पे। ये जो डबल लाइन है, वो डबल चौड़ी वाली जो स्ट्रीम या रिवर या नाला व्हाटएवर वहां पे होगा उसको दिखा रही है। एक लाइन वहां पे वाटर बॉडी को दिखा रही है, क्लोज्ड वाटर बॉडी को। और वो आप पीछे पूरी एक फोटो पे दिख रहे हैं जो कि एक स्केल्ड मैप है। तो आपको ऐसी डेंस टेरेन वाली जगह पे बार बार जाके चेक नहीं करना है कि जिस जगह पे इन्होंने रिवर दिखाई है उस जगह पे वाकई में रिवर है या नहीं है। यू हैव अ विजुअल प्रूफ ऑफ इट, जो कि आप अपने सिस्टम पे अपने ऑफिस के अंदर बैठ के देख सकते हैं। So this is a very good advantage of modern survey technology. तो अभी जो हम बात कर रहे थे that was all of सैटेलाइट फोटोग्रामेट्री, जो कि मैंने बताया हाई ऑल्टीट्यूड से इमेजेस ली जाती हैं। जब कोई बहुत बड़ा एरिया हमें मैप करना है, वहां पर इस वाली टेक्नोलॉजी का यूज होता है। डेफिनेटली इसकी एक्यूरेसी थोड़ी सी कम होती है बिकॉज ये बहुत हाई एल्टीट्यूड से ली गई है, इमेज रेजोल्यूशन ही कम होगा, तो एक्यूरेसी भी जो रिजल्टेंट है वो कम होगी। लेकिन आपके इस तरह के प्रोजेक्ट में वो एक्यूरेसी सफिशिएंट होगी जिससे कि आप अपने आगे की इंजीनियरिंग या डिजाइनिंग प्रोसेसेस कर सकें। द नेक्स्ट थिंग इज ड्रोन, which is widely used in railways these days. Now what is drone actually? It is an unmanned aerial vehicle which is commonly known as drone. It's a flying robot. It can carry camera, sensor, equipments, goods, humans as payload. It can be manual or software controlled. These are some different types of drones which are used, various sensors, technologies, various applications. This is fixed wing drone, this is hexacopter, this is quadcopter, this is also fixed wing drone. So these are different types of drones. Now coming to DGPS. DGPS is an integral part of modern survey technology which helps to achieve better accuracy. So DGPS is differential global positioning system. It is an enhancement to global positioning system. Provides improved location accuracy to 1 to 3 centimeter, whereas normal GPS provides 5 to 10 meter accuracy. Each DGPS uses a network of fixed ground-based reference station to broadcast the difference between the positions indicated by GPS satellite system and known fixed position. This is a DGPS instrument. We have actually drone with DGPS instrument integrated in it. ये देख रहे हैं, ये एक रोवर है और ये जो ड्रोन है इसके ऊपर में ये जो येलो ये विंडो है, इसमें ये DGPS ऑलरेडी इंटीग्रेट किया हुआ है हमने ड्रोन के अंदर, ताकि जो इमेज आए वो खुद ही इतनी एक्यूरेट आए कि जो ग्राउंड कंट्रोल पॉइंट्स है उसका रोल थोड़ा मिनिमाइज हो जाए, हम कम ग्राउंड कंट्रोल पॉइंट लगाकर भी हाई एक्यूरेसी रिसीव कर सके. DGPS integrated drone जो भी मैंने दिखाया, it captures 3 centimeter resolution images from calibrated camera with positional accuracy of 3 to 5 centimeter. अब अगर आपने ध्यान दिया हो, सैटेलाइट इमेजरी में जो हमारी मैक्सिमम रेजोल्यूशन की इमेज थी वो 30 सेंटीमीटर थी. तो 30 सेंटीमीटर की इमेज रेजोल्यूशन, 30 सेंटीमीटर रेजोल्यूशन की इमेज से आप कम एक्यूरेट डेटा पा पाएंगे, और जो ड्रोन है क्योंकि वो बहुत नीचे से उड़ाया जा सकता है, उससे आप 3 सेंटीमीटर रेजोल्यूशन की इमेज पा रहे हैं. तो बिकॉज देयर इज अ डिफरेंस इन रेजोल्यूशन ऑफ इमेज, सो देयर इज डिफरेंस इन द क्वालिटी ऑफ एंड एक्यूरेसी ऑफ द आउटपुट. नाउ ड्रोन इनसाइड. ड्रोन में पहले हम बात, ड्रोन से दो चीजें की जा सकती हैं. ड्रोन से वीडियो भी लिया जा सकता है और ड्रोन से टोपोग्राफिकल सर्वे भी किया जा सकता है. जो ड्रोन से टोपोग्राफिकल सर्वे है वो अगर आप ड्रोन में लिडार लगा देंगे तो वो लिडार बेस्ड एरियल टोपोग्राफिकल सर्वे हो जाएगा, और ड्रोन में अगर आप कैमरा लगा देंगे तो वो फोटोग्रामेट्री बेस्ड ड्रोन टोपोग्राफिकल सर्वे हो जाएगा. लिडार के बारे में हम पहले बात कर चुके हैं. वी विल टेक एन इनसाइट अबाउट फोटोग्रामेट्री बेस्ड ड्रोन एरियल टोपोग्राफिकल सर्वे. मेथोडोलॉजी इसकी क्या है? सबसे पहले साइट रेकी की जाती है, उसके बाद वी एस्टैब्लिश ग्राउंड कंट्रोल पॉइंट नेटवर्क यूजिंग DGPS, देन ड्रोन फ्लाइंग प्लानिंग, एरियल इमेजरी कैप्चर यूजिंग एडवांस्ड ड्रोन्स एंड वीडियो एक्विजिशन. After that, photogrammetry processing and video processing is done with using various steps. पहले aerial triangulation, then 3D photogrammetry data capture, then digital elevation model, then orthophoto generation, and if we are taking video, then video processing. And after that, delivery of the whole outputs are done. तो workflow क्या है? सबसे पहले establishment of GCPs, establishment of local horizontal and vertical control by DGNSS, primary control points establishment using differential DGPS within 1 centimeter accuracy. Additional control points are established using real-time kinematics RTK DGPS approximately 250 meter apart as per site conditions, covering full project area on permanent structure by paint marking, which can be easily identifiable on the imagery captured using drone. Checkpoints additional established using RTK, which are not used in triangulation process, but are used for independent quality validation of inputs. This is a picture how a DGPS instrument works. This is a DGPS instrument. This is how we paint mark and make a permanent a permanent paint mark on a permanent structure. so that it cannot be removed, or it cannot be, you know, if we put a pillar here, there are chances that pillars are thrown off, pillars are taken away, some villagers comes and just pillars को हटा देंगे वहां से. उसको अवॉइड करने के लिए हम पेंट मार्क कर देते हैं, और वो इतना बड़ा करते हैं कि जब हम ड्रोन से इमेज लें उस इमेज पे ये पेंट मार्क आए. फिर इनका हम यूज करते हैं एरियल ट्रायंगुलेशन के लिए. After that, flight planning is done. Flight planning on image after site recce is done using special flight planning application of laptops, considering important factors: flying height, the resolution of the image required, the height of existing structures. सबसे ज्यादा रेलवे के केस में हमें इस चीज का ध्यान देना पड़ता है कि जो इलेक्ट्रिफिकेशन वाली लाइंस हैं ड्रोन उससे ना टकराए, इसलिए हमें हाइट को उससे ऊपर लेना पड़ता है. लैंडिंग एंड टेक ऑफ स्पेसेस, क्लियर वेदर कंडीशन. जैसे मैंने बताया लिडार इज इंडिपेंडेंट ऑफ वेदर कंडीशन, लेकिन ड्रोन के लिए वेदर कंडीशन आर वेरी इंपॉर्टेंट. अगर हेजी वेदर है या बारिश हो रही है या कुछ और प्रॉब्लम्स हैं तो जो आपकी इमेज आएंगी वो उतनी क्लियर नहीं आएंगी, और इमेज क्लियर नहीं आएंगी तो जो आपका फाइनल आउटपुट है दैट विल नॉट बी ऑफ दैट एक्यूरेसी. इसलिए वेदर कंडीशन का ड्रोन के फ्लाइट प्लानिंग पे बहुत ही इंपॉर्टेंट रोल है. फ्लाइट प्लान्स एक्चुअली जो प्रोजेक्ट्स किए जाते हैं दैट इज डन थ्रू ऑटोमेटिक फ्लाइट प्लानिंग. तो ये जो फ्लाइट प्लानिंग की जाती है पहले लैपटॉप पे विद द हेल्प ऑफ सम सॉफ्टवेयर्स, and then these flight plans are uploaded in autopilot of drone for autonomous data collection. In general जो flying height ली जाती है as per the DGCA rules, it is 200 feet. रेजोल्यूशन 200 फीट से अगर हम ड्रोन उड़ा रहे हैं तो जो हमारा टारगेट होता है, जो हमारा रेजोल्यूशन ऑफ इमेज होता है दैट कैन कम अप टू 3 सेंटीमीटर. नादिर एंगल लिया जाता है. नादिर एंगल इज 90 डिग्री एंगल से इमेजेस ली जाती हैं, सो दैट जो भी फीचर्स कैप्चर किए जा रहे हैं टॉप टू बॉटम उनके में कोई भी पोजिशनल डिफॉर्मिटी ना आए. जो इमेजेस की जाती हैं सबसे इंपॉर्टेंट चीज क्या होती है फोटोग्रामेट्री का, कोई भी फोटोग्रामेट्री प्रोसेस से कुछ भी करने के लिए, कि दो एडजेसेंट इमेजेस के बीच में ओवरलैप होना चाहिए. ओवरलैप होना अगर नहीं होगा तो वहां पे 3D विजन नहीं दिख पाएगा. तो ओवरलैप क्या होता है 80% फॉरवर्ड ओवरलैप यानी साइड बाय साइड इमेज में, और 50 to 70% लेटरल ओवरलैप यानी ऊपर और नीचे की इमेज में इतना ओवरलैप लिया जाता है, तब जाके एरो ट्रायंगुलेशन अच्छे से परफॉर्म होता है और आपको डिजायर्ड एक्यूरेसी के आउटपुट मिल पाते हैं. तो एरियल ये फ्लाइंग है कि कैसे फ्लाइंग की जाती है. नादिर इमेजेस दैट इज 90 डिग्री टू द ग्राउंड आर कैप्चर्ड फॉर टोपोग्राफिकल मैपिंग एंड ऑर्थोफोटो डेवलपमेंट. Oblique aerial images are captured at the angle of 45 degree to 75 degree for 3D reality model development to ensure side of the structures and buildings are visible. I will show you in the next slide कि 3D reality model क्या होता है and why we are saying कि side से भी उसकी images लेनी है. Then all imagery captured are geotagged. Geotag means that all the imageries have latitude, longitude and elevation for further photogrammetry processing. This is how what I told you कि overlap image कैसे ली जाती है. लेफ्ट इमेज है, राइट इमेज है, एंड बोथ द इमेज हैज दिस ब्लू वाला, ये वाला जो सेक्शन है येलो सेक्शन, दोनों ही इमेज में ये पर्टिकुलर एरिया आ रहा है और केवल इस ही पर्टिकुलर एरिया में आपको 3D दिखेगा और फोटोग्रामेट्री हो सकेगा. दिस इज अ स्मॉल वीडियो, आप देखिए कैसे किया जाता है ड्रोन फ्लाइंग. ये तो मैनुअल करके दिखा रहे हैं. जो हमने फ्लाइट, ये पूरा हमारा एरिया ऑफ इंटरेस्ट है, इसमें फ्लाइट प्लानिंग की गई है. Then images are captured with overlap of 80% forward and 50 to 70% lateral. All the images are captured. Then they are taken to the system and जो topographical data collection is done. आप यहाँ देख रहे होंगे ये 2 मॉनिटर्स पे काम हो रहा है. One is the 3D monitor. Then the digital elevation model is generated. Volumes can be calculated like this. Profiles can be calculated from this digital elevation model, and we can get a output. So this is what I was telling you about the stereo photogrammetry workstation. It has 2 monitors. One is a 3D monitor, one is a 2D monitor to see drawing. 3D monitor mein you can have a 3D vision. This is a emitter with the help of which 3D vision is done. This is a 3D glass. With the help of emitter and 3D glass, actually 3D vision is seen. This is a 3D mouse, a different kind of mouse having too many buttons to perform various functions, so that work can be done speedily. This is photogrammetry processing. कैसे की जाती है? Images captured from drones are transferred in professional stereo photogrammetry software to develop the accurate and updated topographical maps, which are CAD and GIS ready. High resolution, scale corrected, distortion free orthophoto, contours, digital elevation model, and 3D reality models are generated using this. This is aerial triangulation. I already told you about this. It is a mathematical process of establishing precise and accurate relationship between the individual image and ground. This is how stereo digitization is done. This is the layer list. With each layer list, we just select, for example, we have to make railway track. We'll select the railway track option and we will digitize all the railway track in that particular layer only. And likewise, all the features are done. We used to keep different colors, different size of the, you can say different weight of the lines, so that you can easily distinguish between different various features. Now this is digital terrain model. It is true digital representation of 3D terrain surface for engineering purpose. DTM is made of elevation points and abrupt changes marked by 3D break lines, representing elevation of surface. Fewer points can describe very flat or evenly sloping ground, and more points can be captured to describe very complicated terrain. This is an image of digital terrain model. This is the real image. This is the orthophoto, and this is the digital terrain model of this particular ground for which this orthophoto. You can correlate each and every height difference from here. आप यहाँ देख सकते हो, यहाँ पे ऐसे सीढ़ी सीढ़ी जैसा स्ट्रक्चर दिख रहा होगा आपको इमेज पे, और वही स्ट्रक्चर आपको डिजिटल एलिवेशन मॉडल पे दिख रहा है. And same the color wala jo I told you, the concept, higher elevations are shown by red colors and its gradients, and lower elevations are represented by blue colors and its gradients. This is high resolution DEM developed, which can be opened in CAD software, and elevation on any location may be obtained just by a click on computer. This is array of point. कहीं भी क्लिक करिए आपको उस जगह का एलिवेशन मिल जाएगा. आप कहीं भी एक लाइन खींच के देखना चाहे तो आपको क्रॉस सेक्शन और एल सेक्शन सब कुछ मिल सकता है. This is what I told you about. This is profile generation. This is a cross section of this particular area. ये जहां से जहां तक ये येलो लाइन खींची हुई है, ये उस जगह का प्रोफाइल है. यहाँ पे आप देख सकते हैं हाइट्स है और ये कौन सी उनकी लोकेशंस है उसके हिसाब से. Now orthophoto. Orthophoto is an aerial photograph that has been geometrically corrected by a photogrammetric process called orthorectification. Once an aerial photograph has been orthorectified, it is commonly referred to as an orthophoto. Advantages of an orthophoto: it is very high resolution visualization of the project site. An orthophoto can be used in GIS, CAD, engineering design software to measure true or real life distances, area, angle or features within the photograph. collection of various information such as railway tracks, structures, assets, land, etc. in vector format because it is an accurate representation of Earth's surface. This is example of a orthophoto जहाँ पे आप देख पा रहे होंगे एक एक रेलवे ट्रैक, उसके डाइवर्जन्स, उसके जॉइंट्स, एवरीथिंग इज सो मच विजिबल. और ये तो अभी मैं आपको प्रेजेंटेशन मोड में दिखा रही हूँ. अगर आप डेटा देखेंगे तो आप इसको भी और जूम कर सकते हैं और ज्यादा प्रिसाइजली फीचर्स को देख सकते हैं. Factors for accurate data from photogrammetry: calibration of sensors and camera, stable platform, stable drone, precise direct georeferencing of aerial images, DGPS integrated drone, GCP accuracy in X, Y, and Z, also distribution in project area, precise aerial triangulation as per ASPRS standards and NSSDA report, data collection in stereo photogrammetry environment, ना कि automatic, NSSDA reporting for DEM, orthophoto and digital drawings. So if we take care of these particular factors, अगर हम ये चेक करें कि कैमरा का सेंसर कैसा है, कितने रेजोल्यूशन की इमेज खींच सकता है, ड्रोन या जो भी या एयरक्राफ्ट जो भी प्लेटफॉर्म आप यूज कर रहे हैं वो बहुत ज्यादा हिल तो नहीं रहा है, अगर हिल रहा है तो उसमें IMU यूनिट्स हैं कि नहीं, उसको कॉम्पनसेट करने के लिए DGPS इंटीग्रेटेड ड्रोन होगा तो वैसे ही उसकी इमेजेस की एक्यूरेसी बढ़ जाएगी. जो ग्राउंड कंट्रोल पॉइंट्स हैं वो प्रोजेक्ट एरिया में इवनली डिस्ट्रीब्यूटेड होने चाहिए. ऐसा नहीं है कि 200 किलोमीटर का एरिया है और 2-4 किलोमीटर में ही वो GCPs केवल हमने मेजर कर लिए. इसी तरह जो एरियल ट्रायंगुलेशन है जो कि फर्स्ट स्टेप होता है किसी भी फोटोग्रामेट्री का, वो बहुत ही प्रिसाइज होना चाहिए. उसकी चेकिंग होनी चाहिए एज पर ASPRS एंड NSSDA रिपोर्ट के बेसिस पे. जो डेटा कलेक्शन है बहुत से लोग करते हैं कि उसको ऑटोमेटिक मोड पे कर देते हैं, तो उससे उसकी एक्यूरेसी उतनी अचीव नहीं हो पाती है. इसलिए डेटा कलेक्शन जो है वो स्टीरियो फोटोग्रामेट्री एनवायरनमेंट में, जैसे मैंने अभी आपको सिस्टम दिखाया, उस तरह से किया जाना चाहिए. और जो भी आप डिलीवरेबल्स दें, चाहे वो DEM हो, ऑर्थोफोटो हो, ड्राइंग्स हो, उनकी रिपोर्टिंग होनी चाहिए कि वो एक्यूरेट है या नहीं है. अब हम लिडार और फोटोग्रामेट्री दोनों की बात कर चुके हैं. नाउ देयर कम्स अ कंपैरिजन कि लिडार ज्यादा अच्छा है या फोटोग्रामेट्री ज्यादा अच्छा है. दोनों ही मॉडर्न सर्वे टेक्नोलॉजी है. अब इनमें से दोनों में से कौन अच्छा है उसका एक मेजरमेंट, एक कंपैरिजन है. लिडार क्या है? इट कैन सर्वे अंडर वेजिटेशन. प्लस लिडार इज फास्टर कलेक्शन एंड प्रोसेसिंग. It can give you accuracy of 5 centimeter. It is reliable because it is less process dependent. The pricing is high because जो sensors होते हैं they are very costly. It is visually less appealing क्योंकि पॉइंट क्लाउड होता है, जरूरी नहीं है सब उसको इंटरप्रेट कर पाए. हालांकि हम उसके साथ एक वीडियो देते हैं, बट वीडियो कैन नॉट बी कंपेयर टू ऑर्थोफोटो विच इज गिवन इन फोटोग्रामेट्री. सो फोटोग्रामेट्री में क्या है? मैनुअल मेजरमेंट किए जाते हैं. टाइम इज स्लोअर कलेक्शन एंड प्रोसेसिंग क्योंकि ड्रोन जो है वो एक दिन में कितना चल सकता है उसकी लिमिट है. दिन में ही काम करना होता है, इसलिए एक पर्टिकुलर टाइम विंडो है हमारे पास कि हम उसी समय काम कर सकते हैं. एक्यूरेसी में दोनों की कुछ खास अंतर नहीं है, दोनों ही 5 सेंटीमीटर एक्यूरेसी दे सकते हैं. रिलायबिलिटी इसकी भी बहुत हाई है, लेकिन इसमें प्रोसेसेस बहुत थोड़े ज्यादा होते हैं. प्राइस जो है इसकी कंपैरेटिवली कम है लिडार के कंपैरिजन में क्योंकि लिडार सेंसर इज कॉस्टली देन दैट ऑफ द कैमरास जो कि ड्रोन में यूज होते हैं. विजुअली इट इज हाईली अपीलिंग क्योंकि इसके साथ आपको एक फोटो मिलती है जिसके ऊपर आप डेटा डाल के चेक कर सकते हैं. So we cannot say which one is best or another. We cannot say कि एक बहुत अच्छा है, एक खराब है. उससे ये कहा जा सकता है कि जैसी रिक्वायरमेंट है, जैसे कि अगर डबलिंग प्रोजेक्ट है तो और वहां पे वेजिटेशन नहीं है तो फोटोग्रामेट्री इज गुड. हमें एक हायर प्राइस का प्रोडक्ट लेने की जरूरत नहीं है. लेकिन अगर एक वेजिटेशन एरिया है, एक ग्रीनफील्ड अलाइनमेंट है जहाँ पे फॉरेस्ट आ रहा है, उस जगह पे लिडार इज बेटर देन फोटोग्रामेट्री. सो और थोड़ा सा प्राइस लिडार का ज्यादा है, बट बाकी चीजें इतना भी ज्यादा नहीं है कि वो फोटोग्रामेट्री के कंपैरेबल ना हो। तो अभी हम लिडार और फोटोग्रामेट्री खत्म कर चुके हैं। टोपोग्राफिकल सर्वे, अगर इससे रिलेटेड आप लोग को कोई भी क्वेश्चन हो तो आप अभी मुझसे पूछ सकते हैं।
अब तक जो भी हमने देखा, लाइडार सर्वे, फोटोग्रामेट्री सर्वे वेरी यूजफुल है, और अभी फ्यूचर में यही सब जगह यूज करना है। तो इसमें अगर किसी को कोई क्वेश्चन है तो यू कैन आस्क क्वेश्चंस।
आई थिंक इस बार आज जो हमारे पार्टिसिपेंट्स हैं वो ज्यादातर कंस्ट्रक्शन डिपार्टमेंट से ही हैं। कंस्ट्रक्शन में हम ऑलरेडी इसका कंस्ट्रक्शन डिपार्टमेंट के लिए रेलवे में हम बहुत यूज कर रहे हैं। तो अगर आप लोग को इससे रिलेटेड आपको जानना हो कि किस तरह के प्रोजेक्ट में यूज किया जा सकता है या क्या किया जा सकता है, क्या वे फॉरवर्ड है उसका, अगर आप लोग को उससे रिलेटेड कोई भी क्वेश्चन हो तो यू कैन ऑलवेज आस्क मी।
You can ask questions. You can note down the mobile number and email ID ais@matrix-geo.com. So you can send a mail, you can send a message, call. You can call also if in future if you have any issues. If there is no question, then we'll continue.
So now LIDAR and photogrammetry we have completed. Moving ahead with what else can be done with photogrammetry, with the modern survey technology. So more with using this, digitalization of land map can be done and they can be geo-referenced. We have so many issues with the revenue maps and the land maps. They are not in the good shape, form, and not readily available. So if we can do its digitalization, they can be used very efficiently. The digitalization of cadastral map, georeferencing of cadastral map, superimposing on orthophoto, Google alignment design. It helps in land acquisition process, which is a major challenge for railway when they are, doing their doubling project or the new line project. It's help in improving design and avoid alignment falling on important structure. This is how a georeferenced digitalized land map looks like. This is the example of that. Now we move ahead with the case studies. So orthophoto, it's an information of 2 centimeter resolution on engineer's desktop for measurement. I've shown you this orthophoto. It says orthophoto with asset GIS mapping. Actually, with the help of this orthophoto, you can do asset mapping like this. These are various assets found on railway tracks, so they can be mapped, they can be seen on the orthophoto and they can be mapped accordingly. Every asset has its lat long and chainage and elevate everything. See, details, all the details are available with every asset. Now using aerial survey, this is a topographical survey for DFCC, Rewari Dadri project. It was a greenfield alignment. Corridor width was 120 meters and we had to do engineering grade aerial survey. So this is how the data looked like. This is the alignment. This is contour map of this particular area. This is digital elevation model and this is its orthophoto. So you can actually correlate. Just see, this is orthophoto. That means this is the terrain, how look like. Above it, this is the digital elevation model of this particular area. You can compare it with the shape, how the shape is going, and then how the contours are going. So that is why I'm saying that with the help of modern survey, you can have a very accurate data and you can have a proof that the data is accurate or not with the help of orthophoto. This is aerial survey for Roorkee, Deoband in Northern Railway. This is the kind of data we produced. It was 30-kilometer greenfield project. Activities we performed were control network establishment, aerial photogrammetry survey, old alignment validation and revision, developed L sections drawings and marked alignment on ground. This is a Char Dham RVNL project. It is again a very prestigious and a very challenging project. It was for Matrix Geo Solution, but we conducted it very successfully. So it was 327 kilometer single BG line, 2588 hectares area was mapped. 59 bridges, portal station locations were there, control network establishment, aerial photogrammetry survey, 3D topographical drawing, 5 centimeter accuracy was produced, orthophoto, DEM, 50 centimeter contours were given, and 4K resolution drone aerial photography, videography was also done for this area. This is aerial survey for Char Dham RVNL. You can see the digital elevation, the orthophoto, its digital cross sections, its digital elevation model, and the contour map of the same area. The contour itself predict how difficult the terrain was, how what was the geographical conditions there. This is an aerial survey of Dehradun Haridwar project from Northern Railway. It is 3D aerial survey and 3D modeling. It was done for Anji Khad bridge in Riyasi, Jammu Kashmir. It was a USBRL project, very prestigious project going on for India. So in this, analysis of various aspects were done. This is insight on existing infrastructure, slope, geology, rock, water, vegetation, etc. was done here. This is a small video you can see, Chenab Bridge. It's a 3D reality model. So you can measure the distance from top to bottom. You can measure the perimeters area, or you can say of a building or any structure there. You can also have the volumetric calculation. So this is how volumetric calculation can be done. Just click some points and you can get the result here. It's a very easy task with this. This is aerial survey for bridge location, for bridge improvements. It was done for Nizamabad railway station in New Delhi. There was a bottleneck and survey was done to see the whole area. It is aerial survey for encroachment assessment for in Shakurpur railway station in New Delhi. So apart from these survey, Matrix modern survey technology also includes river aerial survey and underwater survey. So upstream and downstream survey can be done. Riverbed elevation model can be made. Bank condition and watercourse studies can be done. Flood study and river modeling can be done. You can see here, this is an image where Matrix Geo Solution conducted underwater survey also and aerial survey also of the banks. Another technology which comes under modern survey is Eco Sounder survey. Eco Sounder survey is used for river bed mapping because for anything inside ground, sound waves do better than the light rays. So instead of using camera, we use the Eco Sounder. It is a type of sonar used to determine the depth of water by transmitting sound waves into water. The time interval between emission and return of a pulse is recorded, which is used to determine the depth of water along with the speed of sound in water at the time. This is how the riverbed mapping is done at some specific intervals. The cross sections are generated and delivered to the clients. This is how a riverbed mapping look like. This is our elevation model inside river actually. This is aerial plus underground survey result, what I've shown you initially also. So to study the underwater survey, we used Eco Sounder technology, and to do the bank condition study and all that, we used drone survey. This is a picture of Kosi River modeling project, which we did for rides. This is the Kosi River, and similarly we've done a same project for Brahmaputra River also. This is how catchment analysis study can be done. Flood study can also be done using this. For this, we require some basic data like rainfall data from IMD, 25 year, 50 years, 100 years data, maximum rainfall data in 24 years, catchment analysis can be done, drainage pattern analysis can be done, existing structures like dam, barrages, etc. We can show their connectivity and their effect on that particular area. Land use and soil study can be done. Flood modeling and river modeling is done. We have done it for Kosi River and for Brahmaputra River. The results were really overwhelming, and the client really appreciated that and used that for their studies. Then comes the yard survey. Yard is very important feature for railways, and yard can also be surveyed using this technology. So the important the output which we give for yard survey is 3D reality model. It is an accurate mathematical representation of world around railway station in computer graphics, including the point cloud, surface triangles, and real texture of the features. These models are interactive and measurable. Why is a 3D reality model need? Because it provides realistic details and correct visualization of the site. 2D drawing need expertise and time to understand the site, whereas 3D models allow to understand the site faster, especially in complex urban environment. So the uses are, it helps in planning, visualization, and simulation. It also helps to validate proposed plans and identify conflicts with design and effectively discuss and communicate with senior officials. It's an accurately measurable model available on engineers, planners' desktop, help them save time and analyzing what-if scenarios with designs in 3D. So you can see here, these are the pictures of 3D model of New Delhi railway station. Using the 3D model, you can measure the top to bottom distances, you can measure the areas and much more. So this is a small video, kindly have a look into it. Georeferenced orthophotos with drawing. You can see the measurements are being done. The yellow line is showing that. Now the vector images are overlaid on this. You can see each and every railway track and other features. You can see the changes here, and you can measure the distance between two buildings, the area of the building. This is how a 3D reality model of New Delhi railway station look like. This was first yard project done by Indian Railways, and Mectris Geo Solutions executed that. You can see that the FOB bridge is measured here. FOB is measured here. You can calculate the area of the parking lot. These are the additional features, and you can always see the whole scenario, the whole area of site. You can visualize and design. So this is for New Delhi Station Yard, various images for that. This is for Jammu Yard. For Jammu Yard also we did same thing. We delivered updated scale georeferenced yard drawing, orthophoto, DEM, contours, 3D model, and aerial video developed for engineering support. This is for Riva Yard. Same technology, same processes were adopted. This is aerial survey. We also mark the the ESP here. This is a drawing preparation done for yards and open section. This is for Nagpur Rail Metro. Concept overlay on live video was done here, and it really proved very beneficial for them because they were able to visualize the whole scenario on the basis of this. So as I told you earlier also, ROB, RUB planning can also be done using drone. It is reliable, quick and value added data for planning. So this is how you can do aerial survey for, you can get the data from aerial survey of ROB and RUB. And see. So advantages for aerial survey of ROB and RUB are aerial geo video for capturing overview around the manned rail crossing for understanding area, managerial appreciation and faster decision making. Faster topographical survey on the unmanned railway crossing and surrounding. Orthophoto is developed. Superimposition of drawing can be done. 3D reality model by drone is made. Cost-effective way to obtain information. Safety risks associated with traffic control and working in traffic are minimized using use of UAV. Periodic aerial geo video can help in progress monitoring of the under construction bridges also. So this is a classical example. Actually, this slide should have been earlier, that how the quantity estimation, what is the impact of quantity estimation if we use traditional survey and if we use aerial drone survey. Like here, in traditional field survey, points are taken at specific distances, right? And the difference of terrain, the difference of elevations like this, here, they are neglected. So there is a huge difference in volumetric calculation. While if you do survey using drone or lidar, you can have points so nearly placed that each and every nook and corner of the terrain is mapped here, and so the volumetric calculations are done very precisely and efficiently. This is how quantity estimation can be done using modern survey technology. Now we are done with the topographical survey. Another usage of drone is to capture video. So we will go in that. This is drone aerial video survey technology, geospatial video based rail network mapping and monitoring. Geo video captured are very high resolution. Geospatial video using calibrated camera with metadata such as precise latitude and longitude and calibration value. Visualization with Water Insider and application with geo videos integrated with satellite and map based. Integration with existing asset inventory and aid in decision making. So I would like to show you, because time is less, I would like to show you a video on this. Video based monitoring can help in for doubling project. See, you can see each and every stage of construction. You can see what is the stage of construction here using video. You can see there is misalignment of sleeper here because the video captured is of such high resolution that each and every single feature is very easily identifiable and can be taken care of. Analyzing critical locations, like you see there's a building here and a work is already under progress, so you need to take care of this building, what should be done. So you can see everything on the video. This is how another picture of how construction is going on. You can effectively handle land related issues. This is a video from Neemka Thana to Sri Madhopur, and there were land related issues which were seen on the video and then which can be easily eliminated. For effective planning of diversions, video monitoring is very useful. This is a small video which will tell you a lot about it. Rail Insider is a software which I told you. It's customized software for railways. It solves a lot of problems which railway officials face. So it is based on the feedback which we receive from railway officials, and we try to solve all those. Along with the video, you can have a satellite view so that you can see of the video of which location is on your screen at the time. You can increase and decrease the speed of video as per your requirement. If you want to have a Reiki survey, you can increase the speed. If you want to have detailed look of the area, you can decrease the speed and have an enhanced look. You can mark annotations also here. You can mark observations along with coordinates. Here annotation is marked. You can add it on the alignment itself and save it so that you can refer it to your ground, to the person who is going to the ground. It can see and rectify those things. You can see your alignment on Google Earth so that you can have always have an idea of which location the video is going on. A very important feature of this software is that you can compare two videos at a time. The bottom video is during the construction stage, and the above video is when the construction has been done. So you can compare the construction stages. You can compare in 3 months time or 1 month time what progress has been done in the project. You can search the structures also using the Chainedge. We actually integrate all the annotations on the video and just name the structure and you can search it. You don't need to pan the whole video to go to a particular location. You can see the annotations here. See, in red color annotations are coming. Bridge number, LOC number, LC number, FOB number, everything. We incorporate all the things and you can easily see here. Bridge number, Chainedge. So this was about aerial video. These are some photos captured from the video. Now that was done from drone. That was a kind of aerial survey. Another kind of video can be taken from loco based survey. That is, we mount the camera in front of the loco and you can have a closely viewed video from there. This is also a video showing loco based Rail Insider benefits. It helps in engineering decision support. It is very high resolution visualization, enhances situational awareness. It's time saving. You can see the previous video were taken from a drone, so they were giving you the aerial view, while this video is giving you a front view of the railway track and a more closer view, so that you can even see the things written on your junction boxes or on your light posts also. So this is basically done for asset inventory. Existing railway structures can be mapped, electrical structures, asset reviews, or everything can be seen and taken care of. In this also, because it is also run on Rail Insider software, so in this also it is synced with map and you can always view the location of the video running on your screen. It also has the same benefit like that we seen in drone video. You can have the list of the assets. You can search the assets. You can compare two videos. Everything can be done here. You can visualize the LC locations very closely and you can see what are the problems and what solution you can give it to them. That the major benefit is you can always do these things. You've been doing these things since long, but now this is very comfortable that with the help of this video, decreasing your site visits, you can just view it on your system, and many people can view it together. Many people can have the same video, view it, and take decisions on the same. You can enhance, increase and decrease the speed of the video. You can zoom in and zoom out, and you can also measure the video. Measure the distances, the XY distances, of course, not the elevation. So this was about Loco Incycle. This is Radiance video for Dehradun Haridwar doubling project. Now, for like I told you, modern survey technology is also used for OHE design and projects, for electrification projects to achieve aggressive railway electrification targets. It can be done very fastly and it can be done very accurately, minimizing the site visits. We have done it for Mathura Kalyanpur for 407 TKM. Its scale as-built drawing is developed, soil profile is developed. It replaced foot-to-foot survey. Pegging plans were developed. These are the outputs which we delivered. Design software, AutoCAD was used, layout plans, CSD, SED were prepared, design as per standard RDSO guidelines were done, and tools used for automation of designs process so that it can be done fastly. So advantages of aerial survey in design: reliability is increased. It is time saving because the iterative process of site visit during design, checking and approval of design at IRCON and validation of design on ground has reduced. Enabled quick decision making and automation of design process, helped with the help of softwares which decreased the time and increased the accuracy. So this modern survey technology can also be used for the monitoring and inspection of old bridges, which are, there are some locations in the bridges which are really hard to reach, and since very long conventional technology is being used, which are, I cannot say which are not effective, but yes, they were time consuming, and because they were dependent on the efficiency and the quality, the the skills of the engineer or of the person who is using it, it was not that reliable. With the help of drones, you can go to the places which are hard to reach and you can get the data. These are the locations of the bridges. You can see each Revit here. You can see these locations which are really inaccessible. A man cannot go there. You can see the downside of the bridge also. You can see that rusting is done. You can identify the concerns and then you can rectify it on time. The image from top of the bridge. Other technical services which can be done using modern survey are the ground penetrating radar. It is helpful to identify the utilities. GPR technique employ radio waves. Like I told you, in eco sounder, sound waves are used, which was used for riverbed mapping. Similarly, in GPR technology, radio waves are used to detect the things underground. Typically in 1 to 1000 microhertz frequency range to map structures and features buried in the ground. Ground penetrating radar works by emitting a pulse into the ground and recording the echoes that result from subsurface objects. This is a helpful technology to detect your underground utilities. This is how a GPR works. So the way forward using modern survey technology are for construction projects. You can use it for drone-based aerial Reiki survey, which can be video-based. Adoption of engineering-grade aerial topographical survey with geographical coordinates for doubling new lines and RE projects. Adoption of drone lidar for greenfield rail alignments. Adoption of trolley lidar for doubling RE GC projects. Orthophoto survey for project under constructions, Drone-based aerial project progress monitoring system more frequently for greenfield projects. Yard survey to create updated yard maps for planning and yard remodeling. Work in progress audit for payments, because we can have a precise earthwork estimation using this. In Indian Railways, planning stages, aerial recce for proposed alignment, aerial topographical survey, greenfield alignments or doubling projects, aerial survey of critical under construction project site, aerial survey for OHE design projects. Similarly, for monitoring, progress monitoring by aerial videography of under construction projects, survey of critical under construction project site, loco-mounted geo-video for quick monitoring of doubling projects. For existing networks, it can be useful for on-track, off-track GIS mapping by orthophoto and GPS, land mapping and precise encroachment identification, yard remodeling or station development project, visual inspection of bridges or critical assets in inaccessible areas. These days, railway is widely using drones for, the yearly monitoring of bridges. So DGPS integrated drones-based photogrammetry survey. These are some way forwards for the technology. Drone LIDAR survey for precise topographical survey in heavy vegetated areas. Loco-based LIDAR survey for doubling projects. Geospatial drone aerial video and insider application for greenfield projects. Loco-mounted track-level geo-videos with rail insider application. High-resolution satellite-based survey for high altitude or inaccessible areas. In Indian Railways, it has been used for, one product is the videography, another is photogrammetry survey. So you can have various outputs like geotagged high-resolution aerial video or images. It is used for progress monitoring, for managerial appreciation. Orthophoto, which is a scale-corrected measurable aerial imagery. It is high-resolution aerial imagery and which can be used for progress monitoring with measurement facility in AutoCAD, railway asset mapping and 2D drawing preparations. Topographical map or drawing with all man-made and natural features. 3D topographical mapping, drawing development, yard plans. And these are all compatible to AutoCAD, Bentley and softwares. Digital elevation model can be useful for earthwork estimation, volumetric measurement, slope study, drainage planning, structural planning, etc. 3D reality model, which is an interactive scaled measurable model. It is used for quick 3D measurement, visualization, simulation, for presentation of reality 3D, proposed 3D plans in integrated environment, and analyzing what-if scenarios. So these are the major products which can be used in various things. Other services which Matrix Geo Solution provides are these. These are our clients, reputed clients, apart from railways. So this is all for today. If you have any questions, any queries, you can ask me now, or you can take my number. You can ask me later also.
Excuse me, ma'am.
Yes.
Ma'am, this bridge inspection you have done drone survey.
Yes.
So we could be able to see every features of above the earth and within the earth, ma'am. Can we able to see under the water, ma'am? Anything? Condition of piers?
Sir, as I told you, yes, I told you EcoSounder technology can be used to assess to do underwater study. So
Okay.
we have to mix these two technology. For underwater study, we'll have to use drone. And for above water study, we have to use drone. And for underwater study, you can use EcoSounder technology for riverbed mapping. And in as per latest railway board guidelines also, all the bridges, the yearly inspection of the bridges has to be done using drone. So it is very beneficial.